Most oil and gas operators and regulators run an annual business planning process in which the forward-looking investment plan is reviewed, updated, and approved. This demo shows how our Game AI approach can truly transform this process, both in speed and quality. Many of our clients acknowledge that their business planning process is suboptimal. It often takes a lot of effort to construct a single reference case plan. This leaves insufficient time to evaluate what-if scenarios or to construct alternative strategies, even though the final plan needs to be robust against ranges of value drivers, risks, and uncertainties. When there is only a single plan to approve, how confident are you that this is actually a good quality plan? In our approach, we develop an AI assistant that learns how to construct an optimal plan for any set of inputs, value drivers, and constraints. The game includes key elements and rules such as portfolio details, interdependencies between projects, value drivers, project economics, and constraints, such as capital availability or execution capacity. The game is played by an AI assistant, which learns itself to construct an optimum plan. We then analyze the results and use that insight to test alternatives or different strategies. This demo is based on a simplified example to demonstrate the strength of our approach. Consider a brownfield asset with an extensive portfolio of drilling projects. Each project has a different maturity and can only be executed beyond a certain earliest spud date. Gas is sold through an existing contract, and meeting that contract is important from a reputation point of view. But oil has a higher economic value per barrel. Execution capacity is limited to a single drilling rig. The objective of the game is to construct a plan that executes the drilling portfolio in the optimum sequence. Our first strategy is to simply build a plan that is optimized on project value. This can be done in Excel, but is a good way to check our AI assistant. Here you see a drilling sequence in which each block is a project. Red and green mean oil and gas. The width of the block is the duration. The height of the block is the value. Color shading represents the earliest start year. The middle chart is exactly the same sequence, with the colors representing development and exploration projects. The bottom chart shows the value of the user-defined reward function for a particular sequence, which the AI assistant needs to learn how to maximize. The assistant starts with a pretty random sequence and, by exploring different strategies, learns how to improve the reward. By playing this game multiple times, the assistant finds out how to maximize the reward, and it is able to nicely order the projects in decreasing value. The result is a plan in which oil development projects are accelerated, while gas and exploration projects are pushed out. The problem of this plan is that the gas contract is not met. So we change the rules of the game and tell our AI assistant that it receives a penalty for every year in which the gas contract quantity is not achieved. The assistant needs to learn how to play this new game and how to maximize the updated reward definition. By again playing multiple games, it figures out that the right gas and exploration projects need to be accelerated. The resulting plan is one in which the gas contract is met for some years at the expense of early oil production. The obvious next question is how to get both oil and gas production early, and what investment levels would that take? So we update the game definition to add a second drilling rig, and again use the assistant to propose a new strategy. And owing to the additional execution capacity, we get a plan that spends a lot more in the early years, but also accelerates both oil and gas production. This simplified example shows the strengths and flexibility of our approach. We can very easily change the inputs and the rules of the game to reflect different constraints, uncertainties, and value drivers. One of the interesting elements is that we can play the same game from different stakeholder perspectives, which gives valuable insights. Our Game AI approach speeds up the business planning process with orders of magnitude and gives planning teams the support they need to prepare much better and more robust plans. White space energy, navigating complex decisions in oil and gas through Game AI.